Hi everybody, Miss Ninga here. I wanted to come and give you a nice video to help you with your ionic and covalent bonding stuff. I know many of you were looking at this and were confused, especially since some of the wording on here can be a bit confusing, so I'm going to try and help you out a little bit, okay? So I'm going to be using blue on ionic. Let's see, so basics behind ionic bonding is that it's basically taking two elements and sticking them together. One of them has to be a metal or a positively charged element, and then a negatively charged element, and it sticks them together, and because of their opposing forces they attract. So up here you should obviously read this, because this is going to help you a little bit, even like dropping important words in there to try and help you out. So I'm going to come down here. Critical thinking. What charge will group 2 cations have? So it drops the word cation. If you looked up here, cations lose electrons so that they have an empty outer shell. So this means that they are going to become positive because they lose electrons, and electrons are negatively charged. Okay, these are easy to find. Just take out your periodic table and find group 2. Group 2, their charge is always going to be +2 because they have 2 valence electrons, and it's just easier for them to lose those 2 or like give them away. So they will have a +2 charge, which is what you'll write in here, which is +2. Okay? These two you should hopefully be able to answer just by looking at your periodic table and seeing where your elements are. If we jump down here, the directions say ionic compounds form in strict ratios of anions to cations to gain overall neutrality. This basically means that your plus, whatever your positive element charge is, plus your negatively charged atoms put together should equal 0. So down here at 4 it says predict the ions formed for each of the elements below. This is just asking you what their charge is. So if we look at iodine, we look at our elements, find iodine. Iodine is in row 17. They have a charge of -1 because they have 7 valence electrons, and it's easiest for them to try and get 1, because then they'll be at 8. They're closer to 8 than they are to 0. So they want to gain 1 electron. So their charge is going to be -1. For sodium, likewise, you look at your periodic table, find sodium. Sodium is in group 1, and it has 1 valence electron, so it's easiest for it to just get rid of 1 electron, so it's going to have a +1 charge. Okay, I'll do one more. I'll do oxygen. You find oxygen on your periodic table. You see that it is in group 16. It has 6 valence electrons, and so it's easiest to get to 8 by adding 2 electrons, so the charge is going to be -2 for oxygen. Okay, so on and so forth. Just look for your element and then look at what their charge is by taking just by thinking how close is this element to 8. If it's lower than 4, such as 3, 2, and 1, they want to get rid of those electrons, where if they're above 4, they would rather gain electrons. Okay? Number 5 says, form as many ionic compounds as you can from this list and write down the formula of each. Okay. So what this means is you're making compounds using the elements up here in number 4. Okay? So, list. You're using this list for number 5. And all you have to do is choose a negative charged element. So iodine, let's take, and then you need to choose a positive one. So let's choose sodium. And you need to make it so that their charges are 0. Okay? So the first one you always have to have is going to be your positive ion. So that one goes first. So you have sodium. That's its symbol. And then iodine, it's down here. It's I. This is a +1. And iodine is a -1. If we add the charges up together on top, they equal 0. +1 plus -1 equals 0, right? We don't need to have more than one of each of these, so this is the formula, NaI. However, if you're using other, like, mixed numbers, for example, let's use sodium as our first one again. Sodium is our is a +1. And if we use oxygen instead, O, oxygen O is -2. You'll notice, you know, +1 plus a -2 is -1. So that doesn't equal 0. We need to have more of a certain element to get to 0. So since we have more over here, we should probably, since we have more negative charge over here, we should add more positives to balance it out. So in order to get, you know, combat -2, we should have +2 over here, right? In order to do that, just add one more sodium. So if you added another sodium, or have 2 of them, then you just have to add a 2 down here next to your sodium symbol, and this means that you have 2 sodiums and an oxygen. Okay? So on and so forth. Come up with as many as you can using what's up here. Okay. Then there's a little bit more reading. This talks about these things over here, which are polyatomic ions. All they are just some compounds that, when they're put together, have their certain charge. You'll see hydroxide has a negative here. If it is just a single symbol, that means that it is just 1. So hydroxide has a -1 charge. Whereas if it has a 2 and then a symbol, that's the charge. So sulfate here is a -2 charge. Ammonium down here is a +1 charge. Okay? So what's important is when these things combine with other atoms or other ions, you have to put down this entire formula for the polyatomic ion in your chemical formula. Okay? So it gives you examples of those that it wants you to look at here. Okay? I'm going to bring up another copy of my sheet here with my polyatomic ions, just for easy reference. So for this, let's look at the first one here, sodium hydroxide. So for number 6, it just wants you to write down the formula of your compound, and remembering to put your cation or your positive ion first. So sodium hydroxide, sodium, again, looking at our periodic table, is over here, has a +1 charge. So sodium hydroxide has a +1 charge. I usually like to put the charges up here so that I can do the little math before I write my formula, so that I know exactly how many of each I need to write down. And hydroxide up here is a -1. So +1 plus -1 equals 0. We don't need to have more than one of each, so all you got to do is write down your formula, NaOH. Okay? Let's do a different one that has maybe a little bit more complicated numbers to it. So we have sodium sulfate. We have sodium again. Sodium, I'm going to put my numbers over here. Sodium's a +1, and sulfate is a -2. When we add those together, we can see that we don't come up with 0. So in order to do that, we need to add more positives. So we should have 2 of these. So times this by 2. So then we have 0. So that means we need 2 sodiums and 1 sulfate. So we're just going to write down Na. We need 2 of them, and sulfate, which is SO4. Okay. Let's keep going. Let's do a few more. Magnesium hydroxide. That one's just like this one up here, pretty much, only we're going to be looking at it the opposite way. So magnesium, we haven't encountered magnesium yet. Looking on our periodic table, magnesium is here. It's in column 2, so it has 2 valence electrons, so its charge is going to be +2. Okay, I'm going to put my numbers over here again. It's a +2, and hydroxide is a -1. So if we add those together, we can see that we'd be left with +1. In order to get rid of that, we need to add more negatives. So +2, in order to make this -2, we have to have 2 of them to equal 0. So in order to do that, we have to keep in mind that hydroxide itself is OH. Okay, so magnesium we don't need any more of. We can just write that Mg, which was the symbol. And then OH is hydroxide itself. We cannot write a 2 here because that would not make it hydroxide anymore. That would make it OH2. Okay, and that's not what we want. So in order to have 2 hydroxides shown on the paper, we have to show by putting parentheses or brackets around OH to show that this is the entity hydroxide. And then when we put a 2 next to it, that means we have 2 hydroxides. Okay, I know that's kind of complicated, but it's just like in math. In order to separate out your equations or like things from each other, you put brackets around it. That's the same thing here. We want OH as an entity all on its own, and so we put it in parentheses. And then when we add the little 2 next to it, that means that there are 2 hydroxides. Okay. Otherwise, the rest of them should be very similar. All you have to do is look at the charges of each of your components, add them up, and try and make your charge 0 by adding more, or adding more of one or the other. Or if you don't need to at all, like with up here, just remember to write your formula in the correct manner. Okay? Otherwise, that should do it for ionic bonding. The next one I'm going to make is going to be about covalent, which is going to start down here with Model 2. If you have any other questions for me, please let me know. I'd be happy to help you out with this stuff. Bonding is really, it's important in both chemistry and in biology, and so being able to understand why things bond together is something fundamental that you should have an idea of. So let me know if you have any questions, and yeah, talk to you guys later.